Hello students, let us solve a numerical example of free falling object. The question is, a stone is allowed to fall from the top of a tower which is 100 meter high, and at the same time another stone is projected vertically upward from the ground with a velocity of 25 meter per second. We have to calculate when and where the two stones will meet. It will be solved as, to solve these type of problem, first of all we have to make a small diagram. Let us consider this is a tower of height 100 meter. A stone is thrown downward. At the same time, a stone is thrown upward with a velocity 25 meter per second. And at any particular location, the two stones meet each other. Let the distance traveled by the stone 1 is h1 and distance traveled by the stone h2 is h2. Now h1 plus h2 is the total height of the tower, that is 100 meter, and t is the time taken by the two stones in reaching their meeting point. In this case, we will use the equation of motion S is equals to ut plus half at square. But since in this case the motion is vertical, so S will be replaced by h and a will be replaced by g, acceleration due to gravity, having the value 9.8 meter per second square, but for the ease of solving we replace it by 10 meter per second square. So let us start from the stone 1. For stone 1, h1 is equals to 0 since it is thrown by the rest, plus 1 upon 2 into g t square, or 1 upon 2 into 10 into t square. This is the equation first. For stone 2, h2 is equals to, it is thrown by the velocity 25 meter, 25 into t plus 1 upon 2 10 into t square, but the stone is thrown vertically upward, therefore the acceleration will be of negative sign, that is 25 into t minus 1 upon 2 into 10 into t square. But from equation 1, the value of 1 upon 2 into 10 into t square is h1. Therefore, h2 is equals to 25 into t minus h1, or h2 plus h1 gives 25 into t. h2 plus h1 is the total height of the tower, therefore 25 into t is equals to 100, or t is equals to 100 upon 25 is equals to 4 seconds. This is the time. The second thing is where the two stones will meet. To find their locations, we will put the value of t in equation 1 for h1 and for h2. Putting it in equation 1, we get h1 is equals to 1 upon 2 into 10 into 4 into 4. On solving it, we get 2 5 is 10, 5 4 20, 4 is 80 meters. And of course, the position of second stone will be h2 is equals to 100 minus 80. That is 20 meters. So these are the locations of the two stones. One is from 80 meter from top and another one is 20 meter from ground. Thank you.